Good morning, students. In my last video, what we saw was how the basicity of an amine depends on the value of Kb. We also deduced the formula for Kb. And we came to the conclusion, higher the Kp value, stronger will be the base. We also know that it also depends on the value of pKb. Higher the pKb value, which is minus log of Kb, weaker will be the base. And here is where we stopped. I told you that next time I'll be giving you the values of pKb values. Look at them. Ammonia. The pKb value of ammonia is 4.75 and it's a weak base. Then methylamine. The pKb value is 3.38, weaker than this, less than this, so it's a stronger base. Less than this, so it's a stronger base. If I go to dimethylamine, the pKb value is 4.22, so it is stronger than ammonia, but weaker than primary amine. In this case, we also see aniline. Can you see this aniline? Aniline has a pKb value which is very high, 9.38. So it's a very, very weak base when compared with alkylamine. So we reach the conclusion that aryl amines are weaker bases than alkyl amines. Let's go to the next page. We are going to continue with the study of alkylamines. If we see the alkylamines, sorry, this was flying, इसलिए मैंने clip लगा लिया. हाँ जी. If we see the alkylamine and their basicity can be compared in two ways. One in gaseous state, another in aqueous solution. In gaseous state, the basicity will depend on the electron donating capacity of nitrogen. Let us see these two. Okay, here there is double plus I effect. So the electron donating capacity of nitrogen increases. Here, look at this. यहाँ ये देखिए, है ना? And in this case, there is 1 plus I effect. So, which is a stronger base? This is a stronger base than this. If we see the order, the tertiary are strongest bases, then secondary, then primary, and then ammonia. And then comes aryl amine. The position of aryl amine comes after ammonia. Okay. We go for alkyl amines basicity in a solution because the reactions are generally done in solution. So the electron donating capacity, now here the basicity will depend on two factors. One is electron donating capacity, that means how much plus I effect is there. And second, it will also depend on solvation of the ion which is formed in the water, So that means solvation takes place by hydrogen bonding. And जितना steric hindrance होगा molecule में, उतना ही हाइड्रोजन बॉन्डिंग स्ट्रॉन्ग नहीं होगा. और अगर फॉर्म्ड आयन स्टेबल नहीं है तो फिर बेसिसिटी कम हो जाएगी. एज अ रिजल्ट वी फाइंड इन एक्वस सॉल्यूशन to know about the basicity, we have to balance two factors. One is electron donating capacity and another is solvation of ions which has been formed. Therefore, we find these two factors balance each other in case of dye. Dye substituted, it has a very good plus I effect. Plus, it can also form hydrogen bond with water. In case of mono, it has very less plus I effect. But yes, it can form hydrogen bond with water. So the trend observed is different for different alkyl groups. Suppose I say this is R is methyl, like this. Then the trend will be DOT, di, 1 monosubstituted, tri, then ammonia, and then aryl. If R is CH2, CH3, let me draw that. CH3, CH2, N, H, H, इस तरह से ये हो गया मोनो सब्स्टिट्यूटेड. तो अगर ये अल्काइल ग्रुप है, देन द ट्रेंड विल बी DTO, डाई ट्राई मोनो. Is that clear? So what we find is, learn this. This is a learning trick. In case of methyl, it is dot. In case of ethyl, it is DTO. All right. This is because in case of disubstituted, both the cases, electron donating capacity and the solvation of ions balance each other.